Problem number 3. This leads me to believe that we need to use the calculator here for part A, because it says 3 decimal places, but the limit as x approaches -2 of g of x, we can take our numerator. Let's factor the numerator, x plus 2 times x minus 2, and then we have the denominator x plus 2 times x plus 3, and we can cancel the x plus 2's. If we replaced x with -2, we would get 0 over 0, which means then we can factor and cancel. So we get the limit as x approaches -2 of x minus 2 over x plus 3, and when we replace x with -2, we get -4 over 1, so we get a limit of -4. Part B, calculate the limit as x approaches -3 from the left. I'm getting kind of lazy with my shorthand. If we just replace x with -3, in the reduced version of the fraction, we're going to get the same value, because no matter what we plug in for x with those two factors that cancel anyway, they're going to cancel. -3 plus 2 is -1 over -3 plus 2, which is -1. So those are going to cancel anyway, so we just replace x with -3 in this numerator. We get -3 minus 2 is -5. Oh, -3 plus 3 is 0. So it's good we clarify things. We simplify our fraction a little bit by canceling that factor. So if we approach -3 from the left, that means -3 from values that are less than -3, so -4, -3.1. That denominator is going to be a negative number, and we know when we have a constant divided by 0, we get positive or negative infinity, and because the signs are the same, we're going to get positive infinity. Okay. On the other hand, when we take the limit as x approaches 3 from the right, we still get -5 in the numerator, and we still get 0 in the denominator, but from the right, -3, we're approaching from values that are bigger than -3. So -2, -2.9, we can see that that denominator will be a positive number, and so we get negative infinity for that guy. Okay, that's part B. All right. And then part C, what are we trying to find here? G of x is undefined at -2 and -3, as we saw. Explain why the limit exists as x approaches -2, but the limit does not exist when x approaches -3. Well, if we draw a quick graph of this, we could see if the limit did exist because we had a removable discontinuity, we remove that factor. So when x is equal to -2, we have a limit of -4. Okay, there's a hole in the graph when x is equal to -2, and the y value is -4, the limit. Okay, so we're not sure what happens before and after that, but we do know that there's a hole in the graph. Well, that's where the limit does exist. Okay, because we could cancel the factor that caused that discontinuity. Okay, and then at -3. At -3, we have an asymptote. So let me put -3 all the way over here. And I have an asymptote there. And we know that as x approaches -3 from the left, we go up to positive infinity. And when x approaches -3 from the right, we go to negative infinity. That goes down there like that. So I guess the best explanation that I would provide would be we have a vertical asymptote at -3, and we have a hole or a removable discontinuity at x equals -2. So when we have a hole, the limit exists. When we have no hole, the limit doesn't exist. Okay, for discontinuity.